One of the most fundamental questions we can ask about a star is, how long will it last? With our understanding of the way stars generate and use energy, we can also answer that question. In this assignment, we'll see how we do this. In this question, we're calculating how long a star can last on the main sequence. The main sequence is the longest part of a star's life, so the answer we get here is a good first estimate for the total lifetime of the star. Note, however, that not all of the stars in your constellation are main sequence stars. For that reason, as we do the calculation, we'll need to make sure we identify which stars are on the main sequence and, where possible, focus on just those stars. There aren't any specific values that the question tells us here, but one important thing it mentions is that this calculation is very similar to one we did earlier when we were calculating the mass energy available to a star. It would be worth it to go back and look through that mass energy calculation as you work on this one. In this question, you're being asked to predict which star will have the longest main sequence lifetime. As we mentioned above, not all stars are on the main sequence, so to do this properly, you should restrict your choice to main sequence stars if you can. Remember that main sequence stars have a luminosity class 5. If you have fewer than 3 main sequence stars in your constellation, then you can also look at the others. To make your prediction, remember that stars' main sequence lifetimes depend on their masses and luminosities. Use what you know about how a star's lifetime depends on these to decide which main sequence star will last longest. Make sure you explain why you made the choice you did. You should also say whether or not this longest lifetime will be more, less, or the same as the Sun's 10 billion year lifespan. Once again, compare the star's mass and luminosity to the Sun's to decide if it will last a longer or shorter time. Here is the main sequence lifetime equation. M here is the mass of the star in kilograms, C is the speed of light, and L is the star's luminosity in joules per second. The 0.0007 out front is simply a measure of how much of the star's mass is converted to energy while it's on the main sequence. When a star isn't on the main sequence, this number gets smaller, but the calculation is the same. As we said before, the main sequence lifetime equation looks a lot like the mass energy equation, except that the whole thing is now divided by the luminosity. In fact, that's exactly how this equation was put together. We find the main sequence lifetime by simply calculating how much energy the star has available and dividing that by the rate at which it's using up that energy. In other words, the luminosity. There are a few numbers we'll need to look up. We'll need the masses and luminosities of the stars you'll be calculating. You should do 3 main sequence stars, including the one you predicted would last longest. If you don't have 3 main sequence stars in your constellation, then you should include whichever other stars you're calculating. You should also look up the speed of light in meters per second and include that here. We're going to need to convert a couple of the values before we can calculate. One of these is a familiar one, the star's mass. We need to get it into kilograms, so we do the same mass conversion we've done before. In this case, turning 8 solar masses into 1.6 times 10 to the 31 kilograms. The other one is the star's luminosity. Currently, the luminosities are given in solar luminosities, so we'll need to multiply this value by the conversion factor 3.8 times 10 to the 26th joules per second divided by 1 solar luminosity. In this example, this gives 7.6 times 10 to the 29th joules per second. Remember when you do this conversion that if the star's luminosity is more than 1 solar luminosity, then the conversion should give a value larger than the Sun's luminosity. Now we can find out how long this star will last on the main sequence. We put in the star's mass in kilograms and luminosity in joules per second, as well as the speed of light. First, we can calculate the top of the equation. Notice that the units here are equivalent to joules, so we can make that change as well. Then we divide by the luminosity. The value for the luminosity is quite large, so the exponent should be getting smaller here. If it gets bigger, then you know that something's wrong. The time we get is in seconds. If we want to compare this to the sun's lifetime, we'll need to convert this into years. There are just over 31 million seconds in a year, so we can divide by the number of seconds in a year to get the total number of years. This comes out to about 41 million years, much less than the 10 billion years our sun will last. Now you should check and see if your answers match your predictions and seem reasonable. If they do, say so here. If they don't, discuss what went wrong. If you made a mistake in your prediction, then say what it should have been and why. But also look for possible errors in the calculations. Remember that these are the lifetimes of stars, so they should come out to millions or billions of years. Some of the longest lasting stars can last 10 to the 12th years. However, if you start getting lifetimes as long as 10 to the 15th or more years, or if the lifetimes are a few thousand years or less, then you know something is wrong with the calculation. If there's a problem with the calculation, see if you can find it or ask for help. If you run out of time, at least comment on why you think there's a mistake.